Welcome everyone. Welcome to making the most of your Gradle build. I will assume that most of you have already worked with a Gradle build in some way or another. Is somebody here new to Gradle or just getting started with Gradle? No? Okay, perfect. So you might have seen some of the tips I'm going to show today, but hopefully there's going to be something new for you to take home and to make use of these things at your daily work. My job is to make sure that once you come back to your work and you start to work with your builds, you feel like this, like having fun. Building projects should not be painful. And yes, I'm aware that that is no longer the official logo of Gradle. They use an elephant now, but I kind of like the old logo. So that's me. So basically what I want to have is just make sure that your build and my builds work correctly. We don't want to deal with problems with the build. We just want to concentrate the project at hand, which is the actual logic, the actual applications we need to build. My name is Almiray. I come from Mexico. I work for a company, a Swiss company called Canoe. And we do lots of stuff with Java and Groovy and other JVM technologies. And I'm a member of the Groovy development team. I love dynamic languages. I'm also a founder of the Griffon framework and the founder of the AGGREGATE, which, by the way, if you were here at the keynote, you know the AGGREGATE is located on the second floor, on one of the corners next to the bar. We got free beer. It's still called free beer if you want to. And what we do is that we come together and hack on open source projects. As a matter of fact, our first contribution just came out live just a few minutes ago with JDF. So if you want to hack some open source projects, then just come join us at the AGGREGATE. That's basically it. And this talk is based on the experiences that I have had dealing with open source projects and projects with our own customers. So the first thing is, most of you already said off air that you know Gradle in one way or another. So how do you get Gradle installed on your system? Well, the Gradle people, the Gradle website says you download a zip file, then uncompress it somewhere in your platform, configure an environment variable, and then off you go, right? So when the next version comes in, what do? You download the zip file. Maybe you need or not to reconfigure the environment variable and then continue. You have to do this every single time. Wouldn't it be a much better way? Is there a better way to just handle this? Well, it turns out there is. There's this project called SDK Man. SDK Man, it's a very basic, lightweight package manager. So with this, you can install Gradle or Maven and Groovy, Scala, Kotlin, Grails, and a few other tools. This allows you to very easily download one of these projects that are called candidates, just such as Gradle, so that you can install it very easily with a single command line, just like that. SDK install Gradle, and this will install the latest version of Gradle available. You can switch to different versions if you do SDK use Gradle on whatever version. As a matter of fact, if the network is working, we're going to see an example of that. So I already got SDK installed, and I can ask SDK to list all the available versions that it has. So all these are the public versions of Gradle that I can have access to. The ones that have the asterisk are the ones that I currently have installed on my machine. And this one is the version of Gradle that I currently have selected. So if I type Gradle version, then you will see is Gradle 4.2. And I can instruct SDK to use Gradle version 3.5, which I already have installed. So when I call Gradle version again, it now says Gradle 3.5. So notice the following thing, and this works in all POSIX environments. Even on Windows, if you use Cygwin or baboonshell.io, then you should be able to use SDK without any problems. If I call Gradle version here, is it going to be Gradle 3.5 or is it going to be Gradle 4.0 or something else? Remember that this shell is 3.5. but my global setting was set up to 4. So you can keep different versions of the candidates in different shells. So in this shell is a temporary 3.5, but this is my global setting to 3.4.0, and I can set it to anything. So it's now much easier to switch with different versions if you let ETIQUETTE man handle the versions for you. Isn't that cool? I will say so. So the next one is, how do we initialize a Gradle project? In the old days, when we used to work with ENT and sometimes in Maven, what do? We do copy and pray. We copy an existing build, modify it to see if it works with our current project, then run it and pray that it actually works. In the case of Maven, we got one step further. We got archetypes. So we can bootstrap a project in a default way or in a standard way and then continue going on. Well, it turns out that Gradle does not support the concept of archetypes yet, but it has one feature called a Gradle init. If you go into any empty directory and call Gradle init, it will create the very basic structure of a Java-based project. And it can also be used to migrate an existing Maven project into a Gradle one. Let's see, I think I have an example of that. Let's move into, remember we have Gradle 4.0 here. So let's change into a default directory. Let's call it Debox. And let's do Gradle init. Yeah. Now, we got these files without the Gradle wrapper. We're going to talk about that in just a moment. The build file, and that's basically it. If we look at the contents of this file, it tells you with some documentation that it is a Java project. You can define a repositories block, and you can add as many dependencies as you want. This is just as basic as it gets to starting a simple base Java project. If you happen to have Maven multi-project, let's see, where is this thing? I think I have it somewhere in the, should have researched this before. I think it's in the Java 1 folder. And no, I don't have a Maven project right now that I can change. And it will take me a few moments. I should have prepared this before. But trust me, when you call Gradle init on a Maven project, it will generate all the Gradle files for you. And it will only migrate the dependencies, because it's impossible for Gradle to determine if you have a custom Maven plugin, what will be its correlated Gradle plugin. So if you have custom build steps in your Maven projects, you will have now to find if there is a matching Gradle plugin for your new build. We'll see about that in just a moment. There is also another way to initialize Gradle projects, or as a matter of fact, any kind of project, if we extend the concept or archetypes to go beyond just Java projects. And that is using another tool called Lazybones. Lazybones can also be installed using SDK, so just do SDK install Lazybones and you get the latest version. And once you do that, you gain access to a default set of project templates. So you can think of Lazybones as archetypes. But I'm going to showcase two things that make it different and make it better, even for bootstrapping standard Maven projects. If you have Lazybones installed, then you can say Lazybones list. And this will list all the different templates that you currently have available. For example, I can initialize a Gradle plugin project, or a basic Ruby leaf, or maybe it's an ASCII doctor project. And in the case of Griffon is one of my pet projects, you can initialize a desktop application. So let's pick this one, for example, JavaFX Java. We do Lazybones. Let me delete the Devox project that we had. So now we do Lazybones, create the name of the template, JavaFX Java, and give it a name. the name of the application. Now, just like an archetype, it will start asking me some basic questions. I'm going to accept all the defaults. So the group ID, artifact ID, version, blah, blah, blah. And boom, I have created a new project. And there's plenty of information out there. Some XML files, some Java files. And this project, as it is should be able to run right now. We should be able to see a very basic JavaFX application, nothing fancy. Just like a Maven archetype, it allows you to bootstrap your project very quickly. Now, in particular, if you're familiar with Rails or Grails or some other projects related to that, so just like Griffon, you can create new artifacts based on responsibilities, for example, views or templates, controllers. And these new artifacts, these new files, will follow certain pattern. It will be great, you will be able to create them using some kind of template. What Maven archetypes don't allow you to do is to create new files on your project. Because once you bootstrap the project with the artifact, the archetype, then the archetype is meaningless. There is no relationship with the project. But with Lazy Bones, there is still one relationship right there. So say, for example, if I see the information coming from controllers in this place, there is one controller right there. I want to create another controller like this one. I know I can do copy-paste, but I have to figure out if I rename all the places correctly. But what if I were able to generate a new set of files, and this will be an artifact, and this will ask me, what do you want to generate? Is it a controller? Is it a service? Is it a view? Let's see with an MVC group is. And it asks me, hey, it remember the package that we specified when we created the application. So let's use that default. And now it will ask me for a class. Let's say foo. And it has generated a set of files. So when I look back again into the information contained on this directory, now have the right file. And when I inspect the contents of that artifact, well, here is the DevOps controller, and here is the foo model. Look, it did the right thing. Now, this is just a default template, but it allows you to see if you want to create web applications that have a very specific set of components, then you can create your own basic Lazy Bones templates that allow you to do this. As a matter of fact, we have done it with a few of our customers where we have to create a series of applications that follow certain pattern for this organization. So we create a series of Lazy Bones templates that allow us to bootstrap very easily the new application. If you have any questions at any time, please let me know. So the next one is fixing the Gradle version for a particular release. Because one thing that Gradle strives to is to make sure that we have fast builds, but also reproducible builds. And in order to get reproducible builds, we had to be sure that we had specified every single version for all the plugins, for all our dependencies. Never ever, please, seriously, never ever use version ranges in any way. Not in Gradle, not in Maven, not in NAND. Don't do that. If you do this, your builds may not be reproducible. You might encounter some build artifacts that are incorrect. So please never use version ranges. There's a special case for snapshots. Never use version ranges, and if you can, avoid using snapshots. We'll see about that in a moment. So how do we make sure that if you have a build today, that everything works all right? When an auditor comes to your office in 6 months from now and you say, I need to have the same artifacts as you built 6 months ago. How do you make sure? All your versions have to be set. Well, you can set your JDK version, and you can set all the plugin versions, but did you set the tool version? Well, the easiest way to do this is using the Gradle wrapper. And it's such a great feature that there is now also a Maven wrapper. So with this, you're fixing the version of the Gradle tool to a particular number. So now you can assert that every time you invoke your build, it's going to use that version and only that version. If you have locally a different version of Gradle that is bigger or lower, it doesn't matter. As long as you use the wrapper, the same version is going to be applied. If you happen to be a plugin author, then it's recommended that in the Gradle properties file, you change from -bin to -all. This will give you access to the sources of the Gradle API. So when doing debugging or researching the API, it's much better than using a decompiled class. Invoking Gradle anywhere in your project. And this is very specific for multi-projects. So let's see something, for example, a multi-project build that I have here. Surprise, surprise, the Griffon build that has about 48 sub-projects. So we have here some of them, and then let's go inside Griffon core. So remember that I went 2 directories inside. So 2 directories up, I can see the Gradle wrapper file somewhere. There's the Gradle directory, the Gradle wrapper, and the one for Windows. So if I want to invoke the Gradle wrapper on my build for this project, what do I do? Usually something like this. Gradle W and then call clean on this. So the problem that comes here is that I need to remember in which level I am on my sub-project. Wouldn't it be a better way if I just could call Gradle anywhere? Something like GW, Griffon core, clean. And this is exactly what I'm getting to. This GW is an alias for a project called GDub. And GDub, as you can tell at the top, it tells me I'm invoking that particular Gradle wrapper file, hopefully it's the right one based on your project, and I'm invoking that particular build file, which happens to be the root. So now it doesn't matter how deep I go. I can go into source main Java, Griffon util, and up that location, and I can call GW again, and it works. And I can do it inside any directory within my multi-project setup. So installing GDub is easy. You go to that URL. It's a simple script. Just clone that repository. There are a series of steps, like 2 or 3 steps to get it installed. And this allows you to install, to execute the Gradle wrapper anywhere. So the next question is, what if we didn't follow tip number 3 and did not install Gradle wrapper? No worries. GW will try to locate your global Gradle if you have it. If you do, the build is going to work. But if you do not, then the build is going to fail because there's no way that GW is going to find the right Gradle to be used for your build. I tend to use GDub all the place where I can. When I encounter one of our customers, when we encounter a new Gradle build or they're using Gradle, I let them know about this tool because it actually saves you a lot of time trying to find the right files in the right location. All right, the next one is multi-project setup. And here we have to deal about your favorite editor. So I guess most of you use a Java-based editor. Who uses VI for writing Java files? Yay, my people. Emacs? Any kind of non-IDE editor? Right? So when we start using these kind of editors, and in all our multi-project builds, we have a standard naming for our build files, which is build.gradle. So if we have, like, I don't know, 10 sub-projects, we have 10 build.gradle files. And we open all of them in our tabs. What's the name of the file? Again, build.gradle. So we start changing things like crazy. Did we change the right build.gradle file? We can make mistakes. Now, an IDE will probably give you what is the correct name of the project because it renames the tab. But, well, a second. Oh, it's happened again. This just happened on Monday. Anyway, so what if we were able to use a different naming conventions for these files? So it doesn't matter if you're using an IDE or a simple text editor, you will know what is the proper file you're changing. So what I suggest is that we change the names of, what's going on with the screen? Just went black. That's not good. There we go. Not that one, but this one. To change the name of the file from build.gradle to a naming convention, for example, the name of the project. If we do this, we have to tell Gradle that it has to use our new convention. Luckily for us, the settings.gradle file happens to be, first, a Groovy script, and second, it's loaded before everything else from our build is executed. So this is the right location where we can configure additional settings for our projects before they get executed. Say, for example, that you have a project where your subprojects are divided in other subdirectories like common, full, and light. And inside all these three directories, you got all your subprojects. It's just a two-step, and that's it. So inside settings.gradle, I'm going to put this code. And what it's telling me is, it's going to look until all these directories, and for each directory, it's going to ask if it has a matching Gradle file with that name. If it is, it's going to include that path. So here, we're just telling Gradle, I'm going to include these files. The great thing about this is that you want to add a new subproject to your build, just create a new directory inside this, add the proper name for that build Gradle file, and it's done. There's no extra configuration you need to do. The additional code that you have to add to settings.gradle is found in the following slide. Basically, what we're telling is iterating all the children projects, obtaining the real name, this is the name of the build file, and then what we need to do is update this property. Instead of Gradle finding the project in the default location, we're telling it to find it at this other place. And because, again, this is a Groovy script, we can do stuff like this. We're asserting that our changes are correct. Because if we made a typo on the directory name or a typo on the file name, this thing will tell me, something is wrong. So with these settings, now you should be able to do something similar as we have in other places. So let's go where I was here and do an ls. And you can see that there is a Griffon core Gradle file. And I believe I did things manually in this case. Let's go into settings.gradle. And in this one, I am including things manually. But I use the same code to process that is actually doing the right thing. Okay, next one. The build file etiquette. And this is one of the main complaints that people get or say when they're getting into Gradle. I will tell you what the build file should not be, or it should definitely not this. When you encounter a build file that is about 500 lines of code or more, that's a code smell. Something is happening here. The build file is doing perhaps too many things. It has too many steps that are very specific to that project. It could be the case that some of that behavior can be abstracted into a plugin or a set of different things that we can later apply back. Now, my suggestion is to keep the build files dry, so we embrace the power of the conventions. The great leap that we did from Ant to Maven was we gained dependency resolution, and we got the power of conventions. The great leap from Maven to Gradle is that the object module is much richer, but we also have the conventions. So if plugins and the build file and the core settings give you those conventions, please use them as much as possible. That will allow you to reduce the amount of code that you put in your build files. I also try to follow this approach, which is in your build file, you define how your project deviates from the convention. So if your project sources are in source main Java, there's nothing that you need to specify. But if for some legacy constraints your sources live under /sources or source Java or something like that, That used to be the case in AND, remember, no conventions. Then you must specify those things because this is how your project deviates from the standard convention. If you can, rely on secondary scripts to segregate behavior by responsibilities. What do I mean by this? The Griffin build it's comprised of many subprojects, but in the Gradle directory, or you can point it anywhere you want to, as long as you know where they are. Anything that is related to code quality, for example, licensing check, or JDepend, or PMD, I put that inside the code quality script. Anything that is related to code coverage, be it Jacoco, Clover, Cobertura, goes into coverage.gradle, and so on based on the name. So it might look like we're cheating a little bit because we still have a lot of behavior, but it's now segregated into a specific place. So when you now apply these things in your build file, I think it's code quality, the one that we're going to find. Yeah, you can see something like this. We're applying a specific script to a particular subproject. There is another way. I think we are applying these things to the root. Not exactly. I think we are only doing it for subprojects. So the advantage also by putting this into different scripts or secondary scripts that you can define if you want to apply them to all of your subprojects or just a smaller set of them. Let's go back. Another interesting thing is that, of course, you can define as much code as you want in your build. You can define tasks, which is how Gradle understands how things should be done in your build. You can define it on the same build file. You can define them on a separate secondary script. And you can define tasks very easily by using the task notation, or you can create a new class that is of type Gradle task. If you do so, you can still put it in the script, or you can put it in a different place. It's called build source, which is a directory that is always executed or compiled before your actual build. Or better yet, you can move these definitions into plugin projects. It makes sense when you use multiple usages of this task in different projects. And in terms of applying plugins, there are two syntaxes. There is the old school and it's the new way. Personally, I prefer the old school. The old school uses the build script syntax, and the new way uses just the plugins block. The old DSL allows you to specify the location, so the repository where you can find the dependency and which dependency you're going to apply, and then you have to manually apply it in every place. So you have to do 3 things. Whereas the new syntax, the plugins block, allows you to specify the ID of the dependency, and it applies immediately. It has some problems with sub-projects and secondary scripts, so that's the reason why I prefer to use the old school notation. But either way, this is how you make use of plugins in your Gradle build. The next one is, please do not reinvent the wheel. There are many plugins out there, and for that, the best choice that you have at the moment is to go into the official plugins repository from the Gradle company. And the address is pluginsgradle.org. It has a very simple search, and based on your search terms, you may be able to find a plugin that does or performs the task that you need to do. I will give you a short list of plugins that I find very useful in pretty much all projects. The first one is the versions plugin from Ben Mains. This allows you to compute a report of what is the current state of your dependencies, if they are up to date or if they are not up to date. So let's see again here on the Griffin project, and let's call the dependency updates. This is another feature that I like from Gradle, the fact that you can call commands using a short notation and it will expand it. The actual task I'm invoking is called dependency updates. And by using this path, I'm calling it at the root level. So notice that it's actually downloading some metadata from JCenter and Maven Central to figure out if this project has the latest versions of all the dependencies that are described in this project. It might take a bit longer. So while this thing is resolving, so we will eventually see what is the report, let me talk about the other two projects, the other two plugins. The next one is license. The license plugin allows you to do two things. Make sure that all your files have an appropriate license header. This is very important when you're doing open source, and some customers will ask of you this as well. And it also allows you to check which licenses are used by your dependencies. Because I don't know about you, but some of our customers are very picky about the open source licenses that we can use in our projects, especially GPL. So many of our customers don't like to use GPL for obvious reasons. So we need to make sure that we are not consuming dependencies of that type, even transitive ones. So what do we do now? How can we get that information? Well, we can get a list of all dependencies and manually do a Google search. That's kind of tiresome. It would be better if we automate these things, and that's exactly what the license plugin allows us to do. Let's show me, what is this? This project, the Bootstrap project. No. Let's go again into the Griffon project, into the sub-projects, this one, Griffon Core, and then here invoke Griffon Core again. Let me see. All the time? Okay, here we go, thank you. We say download license, or I can just do it this because I'm lazy. That's what we got tools, we automate stuff. And this will generate a report of all our dependencies. There we go. So now we say open, build, reports, licenses, and dependency license HTML. And there it is. Make it bigger. So we got 3 dependencies. These are the jars. These are the versions that we have, and you can see the license agreement. So this will result in a report of all your compile time and runtime dependencies. So if my customer were to use this project and says, I don't want to use GPL, well, there's no GPL there, so we're safe. The other report that was running dependent, remember the dependencies, now it's telling me all these versions are okay, good. This dependency is actually bigger than the one that we currently have cached somewhere in Maven Central, so that's something odd. These other dependencies are not up to date, so please update at your leisure. And for each other dependency, for some reason, the metadata was not found, so it was not able to determine what is the latest version. And you get this information also in a TXT file, so you can post-process this information if you need to. And the final project that I like to use is called versioning, which will give you access to SCM information. So if you need to know what tag or which git commit hash or the message or the author, then you can grab that information using the versioning plugin. But it's not just for Git. If you're still on Subversion or other SCM tools, then the versioning tool will give you that information. And we'll see in just a moment how we can make use of that. It's another interesting thing that you can do with the versions plugin is that you can filter the type of dependencies that you can get by. And this is a snippet of code just copied directly from the documentation of the versions plugin. It's telling me using some basic Groovy code that if any of the dependencies have a classifier that matches any of these regular expressions, then those classifiers are those dependencies are going to get excluded. So when you call dependency updates on your project, you will never get any dependencies which are marked as alpha or beta. You will only get standard releases. So that's a good thing as well. Another thing that I like to do is keep all versions in one place. Everything that can be done in a much more declarative way, I will say should go into Gradle.properties. So say, for example, that you have a file, you have a project with lots of dependencies. I put all my dependencies, such as these ones, in Gradle.properties. And if I can use these dependencies as many times if I want on my multi-project build. And if I need to change one of these dependencies, then it's only in one place, Gradle.properties. Just use it as a regular Groovy string like that. Just use that notation. And that now it becomes much easier to manage the different versions that you have for your dependencies. The next one is dependency versions convergence. And this is a very, very often seen problem in our builds. You are consuming two different dependencies, which transitively have the same dependency with different versions. Say, for example, SLF4J. Someone says, I'm going to use version 1.2.17, which is a little bit old, and another dependency says, I'm going to use SLF4J 1.7.25. Now, we're lucky that these two versions have changes in their fixed releases, so they are kind of compatible. But what if one of these will say SLF version 1 and the other says SLF version 2? We're almost guaranteed that it's a binary breakage when the major number changes, right? So what do we do? Do we jump into OSGI and modular versions? No, that's not the solution. What we do is that we make sure that one of these two versions must be the one that you do require. If you happen to have different versions in all your dependency tree, then there might be a problem. So we can fix that by doing something like this. We iterate over all the configurations and we say, the version of Google Guava is going to be that one. And where is this thing defined? Again, in Gradle.properties. And then, the important thing is this, resolution strategy, fail on version conflict. So now, if two different dependencies include Guava transitively with different versions, the build will fail and will tell you, someone is pulling Guava 19, somebody else is pulling Guava 22, which is the latest one, there's a problem. So you can quickly use dependency insight, another command from Gradle, to figure out what project and which dependency is included in that one, and you can do an exclude, or you can go again and just do a force. So now, even though your original dependency tree says two different versions of the same dependency, you're going to use only one. So that reduces the amount of problems. You can also, I would recommend to supply more information to developers. This is something that we do in the Griffin build, such as this. You can add custom manifest entries to the manifest on a jar. One thing that I would like to do is supply who built the jar, which JDK version, at what time, using the ISO 8601. There, I cannot recall what is exactly and I should, the standard for times and dates, but that's exactly what this format is using. And here comes our, remember the versioning plugin that I mentioned earlier? This is pulling in the latest git commit hash and then adding directly to the jar. So where else have we seen this? A second, the screen is acting up. Here we go. Come on. Macs are supposed to work all the time. Let me disconnect and connect again. Yay. Now you got mirror. Weird. And going to display, where's it? Arrangement. Mirror displays. Here we go. Sorry about that. Works much better. So when we say Gradle version, without that character, we get the date and the time when it was built, the latest hash, and some additional information. So when we add this information to a jar file, to our meta files, for example, here, when we run the application again, this is, remember, the Griffin application. Notice what we have here. The build for this particular Griffin version and which hash and with the JVM that we're currently running. So if you're a user or developer of this project and you encounter a problem, it's just an easy as copying and pasting the initial parts of your log file and then submit a bug saying, hey, this is what I have. And I, as a developer, can say, okay, that's the right version, but the build time is not the one that we publish, and the Git hash is probably not the one that we publish, so you probably are using a version that is not the standard one. So this will allow you to pinpoint the problem much easily. Let's go back to the slides. Next one is incremental builds. Remember, the one of the things for Gradle is to have those faster and faster builds. So since Gradle 2.6, we got a new flag called -t. When you say you invoke a task with -t, it will keep the build working in the background. And if one of the resources associated with the task that you invoke changes, it's going to kick in. So let's see that. Do we have this is the DevOps project? What about the screen? Come on, there is. Okay, so I'm going to do the following thing. GW -t classes. This will compile my project and leave the build running there. It will finish, there we go, it's idle. So now I can go here and say, let's change this to, I don't know, system.out.println. DevOps side effect, invoking a side effect on a setter, save, and the build kicks in, and it compiles Java, and it continues to do the same thing. So it doesn't matter which kind of task you invoke, as long as the observer resources for those tasks get changed, the build will be triggered. It's quite useful. Who here uses code coverage reports in your projects? A few hands. Cobertura? Jacoco? Yay. Clover? So I have found that Jacoco gives you, well, kind of between Jacoco and Clover, gives you a much detailed report on the numbers. And there is a Jacoco aggregate plugin for Gradle, but it doesn't work most of the time. It's only for certain conventions. So what I would suggest is to do things by hand, or perhaps someone can turn this into a plugin. First, we're going to, this is an extra step, but we're going to reuse these values in several places. So we define these as dynamic values on a project. The important thing is this one. We're going to define for each sub-project that requires cobertura, or that requires coverage, that it has to have the XML project, XML report enabled, and we add that project to a list. Where is that list defined? Right there, at the root level. And this is included for every sub-project that requires coverage. Once we do this, we go back into the root project, and the next step is very important. We have to tell the root project to wait until all children projects have been configured, so that at this point, we have the full list of projects that require coverage. That list over there has everything. So now we can merge all the execute-on data of Jacoco to finally generate the report based on all the projects that have that execute-on data. We can define or redefine the locations of all the reports. It's up to you. And with these simple steps, you can aggregate all your Jacoco reports in a multi-project build. Next one, this is only kind of important if you're building Groovy projects. I'm not exactly sure if it's the same case for Scala projects, if you build it with Gradle. But if you do not specify the source and target versions for Groovy explicitly, it will always use whatever version you are using when running the build. If you want to target 1.7, but you're running with 1.8, guess what? The Groovy code will target 1.8. So what do? We make sure that we use the right version. So for all tasks of Java compile, we set the target and source compatibility to some value, which I prefer to define in Gradle properties, and we do the same thing for Groovy compile. So now you change two numbers in Gradle properties, and you can update all your compiled classes. If you're using JDK 8, you might have seen that the Javadoc tool is quite pedantic. If you did not define a params or return tag, or if it has the wrong name for the argument, If you know what you're doing, and you just don't want to be bothered with lots of warnings, then you can tell Javadoc to be quiet. And this is how you can do it. Just pass the quiet flag to it. You can also conditionally activate compiler warnings. You can use something like this. For example, for all tasks of type abstract compile, you want to find if there is a lint or any, I just chose lint just because, a property with this type, this name, and that can be converted to Boolean. You will use it like this. You invoke the Gradle build, pass in -p, defining the project variable, lint equals true, compile. If you set this to false, then the lint will not be executed. That's the whole point why we're passing this to Boolean. If you have had troubles with Groovy in the past, because it's dynamic features, if we don't cast this to a Boolean, and if we set this to true, what is the value of the true string? Is it true or false? It's going to be true because it's a non-empty string. So that's the reason why we're coercing that string to a Boolean value. We're forcing to see if true is true or false is false. All right? Next, guys, we need to get ready. We have to get ready for JDK 9. And for this, we need, the easiest way is to check if we're making use of APIs that will be deprecated or are gone in JDK 9, or not only our production classes, but also our dependencies. For this, there is a new plugin called the JDEPs plugin, which will give you a report of all your production classes and dependencies. And I know for a fact that Guava 22 has 11 usages of illegal APIs. So if you guys are consuming Guava, you will not be ready for JDK 9. And it's as easy, just apply it using old syntax or new syntax, and just run JDEPs, and you will see if you're good to go. Next one, again, makes use of lots of plugins. I listed some of them already, but I can give you a quick rundown. For example, if you want to know how many lines of code your project has, use the stats plugin. You want to publish to BeanTrade repository or JCenter? BeanTrade. You want to create a fat jar with all the dependencies? Use the shadow plugin. Or documentation, or push to a Nexus repository. There's more documentation over there. There are more plugins here. We saw earlier versioning, or you can do mutation testing with PyTest. Or you can generate RPM or Debian packages using OS package, or an Mac OS application using Mac bundle. Run micro benchmarks on your projects using JMH, whatnot. So there's plenty of information out there. Just reuse the plugins. And finally, some online resources. There is the Gradle plugins Twitter account, where I personally handle, when I find a new tip or a new Gradle plugin or something that is very cool about Gradle plugins, I will tweet it. There is the Gradle, daily Gradle account that every time, what is it, GMT5 in London, so that is GMT +1 here, or summertime at 6 o'clock. You will see every day, a new tip on how to use Gradle on many things. I also recommend you to look for Mr. Hackey's blog post on Gradle goodness. He's been writing about tips and tricks on Gradle for more than 3 years now. So it's a really short set of snippets of things that you can have. I think I have 2 more minutes in case that you have questions. I also started to publish a newsletter on stuff like this one. Things that I have seen on daily projects and experiences, to make sure that, well, if you find these things interesting, if you find the tips that you saw today interesting, then please subscribe, and so I have more content for you. So for that, thank you for your time. If you have any questions, I'll be very happy to take them. Yes, over there. The slides, I will publish them on the SlideShare, and I will tweet it using the DevOpsPL hashtag, so you should be able to find them. Yeah, because a few links over there that are good. Any other questions? Well, if you know, well, thank you for being here. You guys are awesome, and keep enjoying DevOps Poland.